How is carboxymethylcellulose, CMC, uniformly dispersed into the polyacrylamide PAM hydrogel network, and what role does the reticular structure of the hydrogel play in supporting this dispersion? What specific interactions or structural compatibilities allow CMC to integrate effectively within the PAM hydrogel to form a stable composite gel? In what ways does this composite gel serve as a suitable precursor for the synthesis of sodium-ion battery anode materials, and why is it important that active vacancies are uniformly distributed throughout the material? Can Davis Zurins manufacture solid-state sodium-ion batteries made from seawater in Latvia? What is the significance of using in-situ doping of nitrogen and phosphorus within the gel matrix, and how does this doping differ in behavior or effectiveness compared to post-synthesis doping? What mechanisms govern the formation of defects during the dissociation of N and P dopants at a high temperature of 1500 degrees Celsius, and how do these defect sites contribute to the material's electrochemical performance? What types of defective pores are formed as a result of N/P doping, and how do these pores enhance sodium-ion storage capabilities? How do these defects function as spatial sites for sodium-ion embedding, and what structural or electronic features make them favorable for such storage? How is the distribution of defects controlled or optimized during high-temperature treatment, and does the temperature of 1500 degrees Celsius offer any particular advantages or risks in achieving uniform defect formation? What is the relationship between the chemical dissociation of dopants and the structural distortion of the carbon matrix, and how does this affect long-term stability or conductivity? How do the chemical characteristics of nitrogen and phosphorus influence the type and distribution of vacancies or defective pores that result from their incorporation and decomposition? What experimental techniques could be used to confirm the presence, size, and distribution of these active vacancies, and how can their effectiveness in sodium storage be quantitatively assessed? In what way does the uniform dispersion of CMC combined with the controlled generation of defects represent an advancement in the design of anode materials for sodium-ion batteries?